Last class we studied about string formatting. We'll see a few more examples of string formatting and why it is preferred over string concatenation. So this particular example, I have two variables declared. One is a string and one is an integer. Now I want to print something like the name of a person and his age. So my output should be something like John is 23 years old. So in this particular example, what I try to do is I am trying to format this particular output. Right? I'm trying to format this output which has one string and one integer value. So in this case, this can be done. The other way of doing this is using my string concatenation, that is using commas. So I got the same result here as well. This is an example of string formatting where I'm trying to format a string which has an integer value and a string value. So if wherever I have an integer value, I need to substitute it with %d. So first I want the variable inside name, which is John, to be printed, and I know that it's a string, so I'm going to start with %s. Then I want is to be printed as it is, so that will have is as a string itself. Then I want the integer, which is age, so I'm using %d. So if you look at the list, %d is for integers, %f is to format float points, and this is again if I want floating numbers along with a certain number of points after your point, like in this case, suppose I want to print something like 65 point, I have this number and I want it to be formatted exactly up to 2 decimal points, that is I just want 65.77. in that case I'll have to say percentage number of digits however I want. Like if I want 2 decimals after my point, then it has to be %.2f. We'll see an example of that as well. Before that, you have to remember this, that %d is for integers, but %f is for float, and your %s is for strings. So this particular example, we saw that I've tried to format the string which is John is 23 years old, where I have two substitutions. One is for a string and the other is for an integer. So wherever I have a string, it has to be replaced with %s, and wherever I want an integer, it has to be replaced with %d. Now after the string is completed, now I have to take care of what needs to be replaced and in which order. So first comes my %s. So this has to be replaced by my variable which is a string, that is your name. Then is my %d, and where my integer variable which is age has to be replaced. So in that case I have since I have two replacements, I need to pass them in a curve bracket. So name and age. If I had another variable, then that would take after that. So in which order I mention this, like name and age, is the same order in which it will be replaced. So my %s will be replaced by the value in the variable name, which is John, and %d will be replaced by the value in the variable age, which is an integer value, which is 23. Now suppose I have a list, right? I have a list here which has the variables 1, 2, 3. Now we'll exactly see in this particular class itself how to create a list. So suppose the other advantage of using formatting is if I want to print all the values that are present in the list, I can use my string formatting as well. So here I have created a list called mylist, and then I'm printing it as, I'm saying a list, and then I'm passing it as a string. That means I'm trying to format this particular list of integers as a string. So the other advantage of string formatting is I can actually format I can change between the types. For example, here I know that my list, which is a list of integers, has only integer values, but I want to format it as a string. So that can also be done using my string formatting. I'm saying printing a list, and after that I want to print this entire list but as a string itself. So in that case I can pass %s, and then after the string has been completed I'm passing my list, which is my list. So that is an advantage of using string formatting, that is while printing. I need to add that here. So while change between the types as well. So this also is one more advantage of string formatting. Right, so this is percentage data. Sorry, this one? List. Yeah, so here I have a list, right? I've created a list. So exactly, how to create a list, we'll see in this class. Let's assume I have a list called my list. So if I print my list, I see that I have 3 integers. Now, if I say my list of 0, it gives me my first element. Now, don't worry about this, but what you should know is the type of the first element in the list. If you check out the type, it's an integer value, right? So since it has 1, 2, 3, they are integer values. But in my example, I'm trying to print integer as a string. That is, I want to print this entire list as a string itself. So in such cases where I'm trying to change the format from one to the other, that is, I'm trying to print an integer as a string, or a float as a string, or a float as an integer, that is when I will be using my string formatting. That is, it's another advantage when I'm trying to convert between the types. That is, when I'm trying to change between the types, I can always use my string formatting. Yeah, sort of, while printing. Change the type between types during printing. That example, don't worry. Okay, now we'll start with today's topic, which is lists. Now, what exactly are lists? Lists are data structures, basically. That can hold as well as type of data. So lists are data structures that can basically hold homogeneous, which means of the same type, as well as heterogeneous, which means different type of data elements as well. They are basically data structures. Now, lists are one very important aspect of Python for ML and data science. So we'll be studying this in some detail. So here, now how do you create a list? Now to create a list, you have 2 ways. One, I can do it using the keyword called list, right? So the first way to create a list, the first one is using the list keyword. So if I say list L1 equals this, that, sorry, I can say L1. Okay, the first way is L1 equals just this. This will create a list. Simple square bracket, simple empty square bracket will create a list by itself. So if I print L1, I can see that I have an empty list here. The other way of, so when I create a list like this, it will result in an empty list. Now if I want to create a list with elements, then I have to manually enter elements here. So here I have created one list, list 1, and instead of the list being empty, I have actually populated it with 5 integers and one particular string. So that's another way I can create a list. So here I have created an empty list using square brackets, and here I have created the same list with 6 elements, 5 integers and one string. So if I print list 1 in the next cell, So to print, I don't have to use the print statement in Jupyter. I can just type the variable name and press shift enter. It will give the list as it is. So this is the small definition of list. They are the most commonly used data structures. The sequence of data enclosed in square brackets. You can have homogeneous as well as heterogeneous types in a list. So here I've created a small list here. So okay, here, yeah. So I've created one list which has 5 elements, right? Now we see that 5 of them are integers and the next one is a string. So this means it can contain both integer as well as string values. So a list can contain heterogeneous values as well, whereas an array cannot contain heterogeneous values. That's one difference between a list and an array. So arrays we'll see a little later. Yeah. Type of an empty list. So I've created one empty list here, a equals. This is an empty list, right? Now I need to, you want the type of a. So if I say type of a, it's going to say list. And if here I have list 1, right? Which is a populated list. And the type of this will also be a list. But okay, so that is okay. Now how do access elements in a list? How do you access the elements in a list? Suppose you created a list and you have, like here you have 6 elements and I want to access the elements in the list. So that is done by something called indexing. So indexing is basically accessing the elements in a list. What exactly is indexing? Indexing, here I have my list 1 which has 6 elements, and if I want to access the first element, that is always done by list of 0. So list of 0, list 1. List 1 of 0 will give you 10. That means I am trying to access the first element in my list called list 1. So here, always know that your length of a list, that is the indexing for a list, will always run from 0 to n minus 1, where n is the length of the list. So if I have 6 elements, it will always start from 0 and end at 5. So here, when I say list of 0, I'm getting 10. List of 1 will give you 20 and so on. Whereas since this is the 6th element, it can be accessed using 5. Today is Saturday. But we know that the length of this particular list is 6. So if I check list 1 of 6, it's going to say list index out of range. It's throwing an error. Means to say that the indexing for any list will always run from 0 to n minus 1, where n is the length of the list. N, length of list. Right? So if I have a list of 10 elements, my indexing will always run from 0 to 9, and I cannot have 10. So here also it will end at 5. Is this clear? This is the most fundamental thing in any array or list, that the indexing of any list will always run from 0 to n minus 1 and not n. So here I've declared an empty list called A, and if I check the type, it is it is a list. But if I look at the type of list 1 of 0, which is an integer value, I see that it is an int. So I'll try to print 2 things here. I will first print list 1 of 0 as well as type of list 1 of 0. We see that it is 10 and int. Similarly for 2, it's 30 and int. But 4 also the same thing. But for 5, you see that it is a string and the value is today is Saturday. So this particular list has both integer as well as string value. It has I can also add a float value. I can say something like this as well. So this is also very much valid. Now list 1 of 6 is a float value and the type is float. 65.65 comma float. So I have 3 types of elements here. I have a float value, I have a string, as well as I have 5 integers. So that also is valid. I can have different types, heterogeneous type inside a list. Okay, so now indexing is used to access single elements in a list. It is used to access single elements in a list. That is, using indexing I can access only one element at a time. Suppose I want to access multiple elements, right? Again I will print that list. I want to access the first 5 elements, right? I want to let's say I want to access the elements from the first element to the fifth element, to the 1, 2, 3, fifth element. In that case, I have to do something called slicing. That is, I have to give a particular slice. I want in list 1, I need to specify 2 things. One is the starting and the other is the ending, right? So I want all the way from 0 till this value. So this is 0, 1, 2, 3, 4, right? So if I go from 0 to 5, I have got all my integers. This is called slicing. So indexing, we saw that it is to access single elements in a list, whereas slicing is used to access multiple elements in a list, right? So again, I'll just repeat this. Indexing is used to access single element. So if I want the third element in this list, I have to start from 0, right? It starts from 0, 1 and 2. So I have to give 2. This is my third element. Suppose I want to access all the elements from the third element till the sixth element, and because my indexing runs from 0 to n minus 1, I want from 0 to 5. I mean, say I want from 3 to 6. In that case, I'll have to give from 2 to 5, right? This gives me the third element, fourth element, and the fifth element. 0, 1, 2. Yeah. Is this clear? Slicing. Okay, so if it's not clear, then I'll print. Okay. Indexing is used to select a single element. Slicing is used to select more than one element from a list. So here, if I want to select all the elements from 20, let's say I want to select all the elements from 20 till 30. We know that 20 is from our indexes, this stands for the 0th index, right? This is for the first, second, third and fourth. So I have to give from 0. Let's see if I give from 0 to 4, I'm going to get only 0 to 4. I have got 20, 10, 20, 30 and 40. So it is selected the 0th element, first, second and third. Because your indexes will always run from 0 to n minus 1. So if I give 4, the last one is always excluded when I'm trying to do slicing. The last one is always excluded. So if I want the 6th element, I'll have to give till 7. So in this case, I want till, let's say I want till this point. I want all these elements to be printed, but not the last one. So in that case, I'll have to give 0 till 7, right? Because I want 0, 1, 2, 3, 4 and 5. 5 means I have to give till 6. So whenever I'm doing slicing, we should remember that the slicing will always avoid the last element. So if I want till the nth element, I'll have to specify the slicing end to be n plus 1. So indexing is used to access single element, whereas slicing is used to access multiple elements. Is this clear? Any doubts in this? Slicing. So we'll see another example here. Last class we learned range function, right? So I will create a list from that itself. I will say range of 10, 100 with a step of 3, right? And I will store this as a list. And I will create it in a variable called AA. Now if I print AA, I see that I have all the elements from 10 till 100 with a step of 3. That is, the gap is 3. Remember this? We did it last class, I think on Tuesday. So from this particular thing, suppose I want the first element that can be accessed using 0. A of 0 is my first element. Similarly, A of 1 and so on. Suppose I want all the way from the first element till the 12th element. So what should be my last index? 13, right? So this will give me 12 elements. The first 12 elements, and the 13th one is avoided because my list always runs from 0 to n minus 1. Right? This is one thing. Yeah, so this is indexing and slicing, how to access elements in a list. The other one is a very important function. It's called Len function. So Len function basically gives you length of a list. Right? So I have my list 1, right? I have my list 1, and I want to, okay, let's say I have this particular list which I just created, which is AA. Now I want to understand how many elements are there in my list. So in that case, I just have to pass that particular list to a function called len, which is my length function. It's a built-in function to get, or which will return the length of a one-dimensional data structure. That's your length function. In this case, it is 30, one-dimensional or n-dimensional also. So if I want to find out what are the arguments that I need to pass, then I can type len. I can go inside my brackets and press shift tab. So I get shift tab. It will give you the function arguments. So I see that it will always return the number of items in a container. In our case, container is a list. Right? That is your length function. Length will return the length of, or the number of elements that are present in a list, array, or any other data structure. That is your length function. So this we saw how to access elements in a list. One is indexing to access single elements, and to access multiple elements we use slicing. Right, now I'll create a particular list. So I have a list of fruit names. I have 5 fruits here. 3, 4, 5. Now length will, as we just saw, length will return the number of elements or the count of elements in a particular list. And here it's saying 5 because X has 5 elements or 5 types of fruits. Right. Don't worry about this. Looping is not required. Now, here I'm trying to create a list, or I'm trying to create a list using both variables as well as actual values, right? So here I have a list called X. I have 5 characters A, O, M, B, K, and I also have variables. One is a float value, the other is an integer value, which I have initialized beforehand. Now it is just to show that these variables can also be part of a list. Like here I have characters, right? I have string values. I have 5 string values and 2 variables, and this also can be part of a list. So if I print X, I have all these values. So to access G, what should be my index? What should be my index for G? 5? 5? G value. 5. You sure? Yeah, 5. Because it starts from 0 to n minus 1. So this will give you your 10.3, which is F. Yeah, you can. We'll see those. So we have 2 types of indexing. One is positive index, which runs from 0 to n minus 1. Right? Now the other index is your negative indexing. This is your X, right? Suppose I want the last element. It can be accessed using X of 6. it can be accessed using x of n minus 1, where n is the length. The other way is it can also be accessed using x of minus 1. This will also give you 10.3. So here when I give a minus sign, it automatically recognizes that the iteration is happening from the back side. So if I give minus 1, it stands for a negative index. It will automatically print the value that is present at the end, or the last item, right? And minus 2 will give you the last but one item. Similarly, minus 3 will give you the last but third item. So this will run all the way from minus 1 till this is m, and this is 6 will give you O, and this will be 7. So it will run all the way from minus 1 till minus, if this has 7 elements, if m is the length, it runs from minus 1 to minus m. So positive indexing is always from 0 to n minus 1, negative indexing is from minus 1 to minus n. So two types of indexing you can follow. So this is exactly what I've done here. 0, 1, 2, 3, 4, and then I've also printed in the reverse order. Minus 1, last element, minus 2, last but one element, minus 3, last but third element, and so on. Right? Two types of indexing, positive as well as negative. Now I've created a particular list here which has two elements, which is, we already have x, right? We already have a list called x which has 5 strings and 1 integer and a float value. Now I have another list called y which has 2 strings. Now I am creating another list z which has 2 elements x and y. So basically z is a list of lists, or it's a 2-dimensional list. So to create a 2-dimensional list, or what I need to do is I have to create one list saying 2D list, which is equal to list 1 comma list 2. This is how you will create a 2-dimensional list, right? That is your z. Now if I try to print z, let's see what we are going to get. We see that it has a double square bracket standing, meaning that it is a list of lists. So the first element here is the first list itself, the second element is the second list, right? Now how do you, so this particular z is made up of your first element, which is your x, your second element, which is your y, right? And it's a list of lists. Now to access the first element of z, I have to give z of 0. That will give my first element, that is the list itself. So z of 0 is basically your x, and similarly z of 1 is your y. Is this clear? Here I am creating, I have one list which is my x, one more list which is my y, and I have created a list of lists called z, which has both the lists x and y. When I print z of 0, I am getting my first list, which is basically your x. When I print my second list, that is z of 1, I am getting my y, which is carrot and potato. Now can someone tell me how do I access the element 10 using z? So z will print this, right? Z of 0 will print this. So what should be the next index? Not comma, it is 2 indentations, 2 levels I need to go. So yeah, I will give you. So here I am doing 2 levels of indexing because z is a 2-dimensional list, right? Similarly, if I want to access potato, I know that it is the second element in y and y is the second element in z. So in that case, if I print z of 1, that will give me carrot and potato, and to access potato it has to be 1. So z of 1 comma 1. Is that clear? A list of lists. So should I repeat this or it's clear? List of lists. Not clear? So this is what we did. So we did slicing also, right? Yeah. The other thing that we need to check. So I have x, right? So I want to select all the elements. So when I'm doing slicing here, we saw that so here I need to specify a start, and here I need to specify a end. So let's say I want all the elements from B, starting from B till 10.3. How can I access that? Starting from B. B here. Yeah, so this is 3, right? 3 to? Yeah, all the elements. Are we getting all the elements? We are not. So it's because it is 1 less. So it is 3 to 7. I'm getting all the elements. The other way we can do it is, if I don't specify an end here, if I don't specify an end, if I just say x of 3 comma and I don't specify an end, that will also give me all the elements from the third index till the end. So this starts for your start, and this represents your end. If I don't specify an end and just the start, it will take all the elements from the start till the end. Suppose I want all the elements from the start till only B, right? So in that case, it is 0, 1, 2, 3. I have to specify 4. So 4, and if I don't specify a start, it's going to take all the elements from, by default, if I don't specify anything, it will take from the, if I keep the start empty, it will take everything from the start. It will take, if I keep the end empty, it will take everything till the end. But if I don't specify anything at all, it will take the entire list. So this is your start, this is your end. You should know how to play with these indexes. This takes all the elements from M, which is your third index, till the end. Suppose I want all the elements, say -1. Yeah, so this gives you 10.3, because I want all the elements from the last till the end, right? And I'm using negative indexing, it's only selecting -2. Suppose I want the last 4 elements, then that gives me from -4 till the end. Is this clear? -4 till the end. Similar to positive indexing, but from the negative direction. -4 is what? It starts from B, right? -1, -2, -3, -4. I'm saying I want all the elements from -4 till the end, so it's giving you B, K, 10 and 10.3. So basically, when you are doing your indexing, the syntax is you have a start and your end. Where the start is always inclusive, that is, it is included. Your end is always exclusive, that is, it is excluded. It is left out. So if I want from 0 to 5, I have to specify 0, 0 colon 6, because 6 will be left out. Is this clear? These 3 things you should remember. One more time. Sorry? In Z. Yeah, we can. So we have Z, right? What do you want to do here? You want all the elements of the first list. Okay. Suppose I want to select MBK. So first of all, it is the first element, right? So I have to do 0. Now inside, so if I do this, it is printing this. Now, as usual, from 0, I want to select 0, 1, 2, 3, 0, 1, 2, 3, 4, so 2 to 5. This is how you will do in slicing for a 2-dimensional list. I mean, he was asking me how to select in Z, which is a two-dimensional list. He wanted to select MBK from a two-dimensional list. So first of all, I need to know that your this particular list, your first list is the first element of Z. So I have to start with Z of 0, right? I have to start with Z of 0, which has these elements. Now inside this I want only MBK. So now the usual slicing, which is from 2 to 5. So Z of 0 of 2 to 5 will give you the same thing. Yeah.
Can you come down? The next one.
Hmm.
Yeah, X and minus 4. It should just take B to A, right? You reverse it.
No, I'm specifying I want, no, irrespective of it, I want all the elements that start from minus 4. Now this minus 4 is a position. And because, here, start and end, right? So it just understands that you want all the elements that start from the element that is present in minus 4 till the end, again in positive direction itself. But if you want that way, in that case you'll have to give from minus 4 till minus 7 or something, right? I think.
So in that case, minus 4 and positive 4 means the same, right?
Yes. In this case, see, here we've got, okay. Let's select this. I will print the same thing, and here I will have 4. No, because minus 4, the index starts from the other way. So, because 4 here will stand for K, whereas minus 4 will stand for B. When I'm specifying this, when I say minus 4 till the end, it just understands that you want all the elements from the index position minus 4, positive words towards till the end. So it's the same thing. What do you want to print the reverse side? B? BMOA. Okay. Let's see this. Minus 4. And you want to go reverse, right? In that case, I can reverse it. This is minus 3 will give you K. From minus 3. You want BMOA, no? So in that case, you can just take starting from 0, AOMB, which is 0, 1, 2, 3. I can go till 4, and I can store this. That is, if that is not working, I can store this in some queue. I can reverse it. These functions we will see. No, there is no way you can do that. You can't do it backwards, as far as I'm aware. Yeah, it's called list dot reverse. This will reverse all the elements in your string. We'll see that in the end as well. But what you asked, right? If you want to do negative indexing and go reverse, I don't think it's possible. But one way you can do it is you can reverse the entire list and then do it. Here. Minus 4 to 4.
Colon minus 4. Because that's what is.
Colon minus 4. This one?
Yes. Now print.
Will this have to? Okay. Now you are getting AOM. No, she asked for BMOA, right?
So minus 3 can be.
No. Yeah, this can happen because it will still be AOMB, but she wanted the reverse in the reverse order. She wanted in this order. She wanted to select in this order BMOA. So what this will do is it will again go from the starting, which is from index 0. It will go till the minus 3 index, which is your B. So again we'll have to reverse it. Slicing as in? How do you want to slice this? This is slicing only, no? We are slicing here only. we are selecting all the elements from the first element till the element with index -3, which is B. So I have another list here, powers of 2, and this again, as you know, will print all the elements. Here I am slicing the list called NUM and I am selecting all the numbers. So this will print all the numbers itself. Yeah, so we'll see a bit of built-in list functions. One is your length, which we already saw what it does. Next, we have a function called max. So this is your NUM, right? It's a list. If I want to find out the maximum and the minimum value in a list, I can use max and min. So here, and I need to pass my list as it is. So here max of num is 20, as you can see, whereas min of num is 2, because it starts from 2 to 20. Right? So that is your max and min. It is clear? Max, min and length, 3 functions. Okay. Now how to add lists? One simple way is I can do a string list concatenation. I can just do a plus. Now I have 2 lists, 1, 2, 3 and 5, 6, 7, 5, 4, 7. I have a small plus sign between them and I'm storing them in a variable called xx. So if I print xx, I see that all the elements have been appended. I have 1, 2, 3 and then I have 5, 4, 7. So a small plus sign will add all the elements and it will merge them into a single list. We are seeing this here. I have 1, 2, 3 as in one list and 4, 5, 7 in one more list, and if I do a plus sign between them or if I try to concatenate them, the elements of the new list are going to be 1, 2, 3, 5, 4, 7.
Will it work with array variables also?
Array?
Array variables.
As in?
Say 1, 2, 3.
Ah.
I'm going to replace with
Strings.
with variable say z.
Yeah, like you're saying this, right?
Assign z with 1, 2 layers and then replace that entire list with z. Yeah.
Saying this, right?
Yes.
Same. Now it will be a list because I am appending z as a list, right? Now if I don't append z as a list, because z is already a list, it is appending it as a list again. So if I just remove the brackets here, it will append it as it is. 1, 2 Shreyas and then 5, 4, 7. Now, so plus operator we have studied type, we have studied length. Now we will study a very important concept called in. Now in is used to check if an element is present in a list. This is what I am trying to check. So this is your in, it's a keyword. How will I use this? Suppose there might arise a requirement where you want to check if a particular element is present in a list or not. Then I am going to use this keyword called in. Let's assume I have a variable called name, a list called names, right? Now here print names, I have earth, air, fire and water. Now, so I want to check if fire, the element fire is there in names. So I am going to say fire in the name of the list, which is names. Now this will always return a true or a false. It's going to return true if this element is a part of this list. It's going to return false if it's not part of that list. So in this case, it is going to say true. So the whole point of in is to check if an element is present in a predefined list. I'll repeat this again. I have a list called names, which has 4 names. right? I'm printing it here. Now this in is used to check the existence of any element in a list. So I have fire in names, and when I execute this, it is always going to return a boolean value. Depending on if that element exists in that list, it's going to return true, else it's going to return false. So here fire in names, because fire is part of my names list, it's going to return true. But we should also know that it's case sensitive. If I replace my capital F with small f, it is going to say false because it is case sensitive. Capital FIRE is present in this list, whereas small f is not a part of names. Typical usage of this is if I have a list of let's say 10,000 elements and I want to check, I cannot go through each and every one of them, right, to check if it's a part of if that particular element is part of that list or not. In that case, I can use a simple function called in, and I just have to pass the name of the element that I want to check in the list that I have, and accordingly it will return true or false. If that element exists in the list, it is going to be true, else it is going to be false.
How do I make it case insensitive?
You want to make it case insensitive? There must be a way. So before you check, what you can do is, I can always do names dot, or I can run a small loop for I in names, I equals I dot I'll convert everything to lower and then check. I can do that. Now if you print names, everything is lower. No. Wait. S equals it is just lower function, I think. It should work ideally, I don't know. I can just print I dot lower. And I can add them back to some list, and then that is one way. There is a way you can do that also. You can actually avoid it being case sensitive. There is a way. Probably after class I'll check that.
So is this in function using the concept of regular expressions?
No, it is just doing a simple search. If you have a data structure or a container, it will search for that element match in that entire list. So the whole point is it saves you a lot of coding time because you don't have to write any for loop. If you don't have to write any looping structure like for, in, or enumerate, such things. Which this particular concept of in does not exist in Java. As far as I remember, it's not available in Java. If you want to check in a list, you have to loop through the entire list. You have to say for I in the range and so on, and then check if there is a match. Huh?
To lower this one is a third element.
In here, so I have names, right? Only fire you want lowercase. So I have names, right? So names of 2 is fire, and if you check out the type of this, it should be a string. This is a string. So all I have to do is names of 2 equals names of 2 dot lower. So now if I print names, I see that the third element has been converted into lowercase.
Can we find out even the location of?
Yeah. Of the
Like when you are searching whether that particular
is lower or is there?
it is there.
Huh.
Can you find out that location?
Yeah, it's possible. I'll tell you. Using in it's not possible. You have to write a separate for loop for that. Like here, suppose I'm searching for fire. In that case, you don't understand it now, but it is something like for I comma ii or for I, or it's basically like for index comma value in enumerate of names. You have to do this. Now whenever I'm using enumerate, you will have two variables. One is an index and a value. So just in will not give you the index. It will just say true or false. It will not even in fact print the value, because see here fire in names will only print if it exists or not. So if you want the index and the value and all, you have to write this particular function. See here, I'll just print this. Index comma. So you're getting this. Enumerate, it will basically run through your entire container, and the first value will start for the index and the second iterator. So your first iterator is for the index, second iterator is for the value. Don't worry about this for now, because we are focusing on lists. So in will only return true or false depending on if an element is present in a list or not, and it will always return a Boolean value. Now if I want to check, I'm just checking if this name is there in names or not. Because it is not there, it's returning false. It's clear, right? In. Is clear? In. Okay. We studied max and min for lists that contain integer values, and we know that it will return the element with the highest integer. Now what if those elements which have string values? So here I have a list of 1, 2, 3, 4, 5, 7 strings, right? And if I print the minimum value in that string, we see that it is printing ALM, this element. And if I print max, it will print NC. Now what is this based on? It is always based on the ASCII value of the entire string. As you know, your ASCII starts from I think 26, right? 26 to 44 or something, or I don't know, it starts from some value, it's from A to Z in the increasing order. So for every string you will have a particular ASCII value, and depending on that ASCII value it will print the maximum string with the highest ASCII value for max of the list name, and if I say minimum, it will print the element with the minimum ASCII value. So in this case it says that the string which is ALM here is the element with the lowest ASCII value, whereas the element with NC has the highest ASCII value. Now I don't know how this is calculated. You can look it up on the internet. ASCII values of alphabets, you can always search for it. So when I do max, it will give you the ASCII value, and I mean if it has only strings, it will give you that element with the highest ASCII value, and for min it will return that element with the lowest ASCII value. So here the first index of each element is considered, and thus Z has the highest ASCII value, and it is returned, and minimum is A, and so on. So don't worry about it. That's all. Few functions. The first one is your list dot append. It will add one element to the tail or end of the list. So here I have names dot append. I have names, right? I have names which has five elements, 4 elements. I want to add a fifth element at the end, then I have to use a function called dot append. Append will add to the end of a list, and whatever I want to add, I have to pass it in this particular argument. So I want to add the string Bangalore at the end of this list. In that case, if I do names.append, and now again if I print names, I'll see that Bangalore has been added here. So it is list.append as a function. Is clear? Dot append. It will add to the end of the list or tail. Now going back a little bit. So we have this, right? We have names now. So if I do max of names, your max and min function will basically, it's saying fire. Now I have another default argument here. One is your key. Key is by what value you want to measure the elements. If I say key equals len, right? When I'm saying key equals len, it's returning Bangalore. That means I am sorting all the elements in my names. I know that it has air, earth, air, fire, water and Bangalore. And when I specify my key as length, it is returning the element which has the maximum length. So in this case it is Bangalore. But if I don't specify anything for a string, control, for a list which contains all strings, if I don't specify anything, then it is according to your ASCII value. But if I specify a particular key which is by length, then it is going to say Bangalore, because it will count the number of characters in each string. So there are two ways. One is just max, and this particular max will return the element highest ASCII value. The other one is max, and I pass a particular variable called key, and if I say I want by length, I have to pass len. If I pass len, then it will return the longest element. Right? Two ways. One, if I just say max, it will return the element with the highest ASCII value. If I do not specify, if I give a key as length, then it will specify or it will return the element with which has the maximum number of elements. Is this clear what this does? So that element is called or that argument is called key. So here if I give minimum, then it's going to be air, because air has just 3 variables. So we did append, right? Append, it will add this element to the end. If I pass any element, it will add that particular element, or it will append that element to the end of a list. Now the other function is called count. What count will do is, it is used to count the frequency of any element in that list, or it is used to count the number of instances of that list. Suppose I have this particular list LST, right? This is what I have. Now I want to find out, so this LST is made up of 1, 4, 8, 7, a lot of 1, 7, 8 and again 4. I want to find out how many times the element 7 has come. Right? I want to find out how many times the element 7 has come. So in that case, I have to say lst.count, and I have to pass the element whose frequency I want. So in this case, lst.count of 7. That will give you 8. That means the element 7 has come 8 times. You can actually count them: 1, 2, 3, 4, 5, 6 and 7, 8. So list.count, it will give you the frequency of the element in the list. Right? We'll see 4 more functions. We saw append, we saw count. So I have LST, which is this list. I also have LST1, which is a smaller list. Now, your append function can also be used to add an entire list at the end of a list. Right, so if you do that, if I do LST dot append of LST1, look at the output that we get here. It's appending. So I'm reassigning it here. So if I print LST, I see that. Okay. Something is wrong. One second. Oh. Yeah, as you can see here, if I try to add a list at the end of one more list, then it is going to add the entire list. So what append does is, it will do 2 things. It will, if I just append one element, it will append just that element at the end of a list. But if I append an entire list, like I'm doing here, I'm appending this list, which is 5428, at the end of a list. In that case, the last element is the entire list itself, right? So what append does is, it will add the entire list at the end of a list. So append function can also be used to add an entire list at the end of one more list. Observe that the resultant list becomes a nested list, right? Is what we got here. We have one list and inside that we have a smaller list. This is using append. Now, to overcome the fact that it is being appended as a list, if I want to append the individual elements, then I have to use extend. Right? If I use extend, I see that, forget about this, I mean I'll initialize that again. Just this. Yeah. Now we see that append added the entire list as it is at the end, whereas extend is basically adding the elements of that list or the individual elements of the list as elements itself. So I do not have that problem where it is appending the list directly. It is just appending the elements that are present in the list. That is the difference between extend and append. So this is a very important question, you can say. The difference between append and extend you should be able to explain with an example. So append will add an entire list at the end, whereas extend will only add the individual elements at the end. Next we have a built-in function called index. Suppose I want, so it is basically used to find out the index value of the particular element. So here I have names, right? Let's do with names. I have names. Suppose I want to find out the elements, the element or the index of the element, which is I want to find out the index of element water. So names dot index, and I need to pass the exact element, which is water, and this should return 3 because it is the third element. So dot index is a function which will return the index of whatever I pass. It will return the index of that element as the output. If I have multiple occurrences of that element, like in LST we see that I have a lot of 7, a lot of 8, and I have repetitions, right? So if I try to find out the index of 7, it will tell, it's going to say 4 because it will give the first instance 0, 1, 2, 3, 4. So it will give you the first index where the element 7 is occurring. So I have LST and I want to find out LST dot index of, let's say I want the position at which the element 8 occurs in the first position. So in this case it is 3, right? So dot index will give you that. Now the other important function is called insert. Insert x comma y. What this does is it will insert the element x at position y. As simple as that. We saw what append did. It will append at the end. But if I want to insert an element at a very specific position, let's say I have your names itself. I want to insert some element between air and fire. That is, I want to insert the element at 0, 1, second position. So in that case, I have to say names dot insert. First thing, I need to specify the index value. So my index value here is 0, 1, 2. So at the second position, I want to insert the element, let's say wind. So this is how it's done. Now if I print names, I see that wind has been added at the third position. So it's always your index followed by the value. Right? Is this clear? Insert. So first is your index, second is your value that you want to insert. Right, few more functions I'll finish off. It's called pop. Now what pop does is it will return the last element in the list. If you have dealt with stacks, you will know. Yeah.
Like the previous example, we can override names. Like
You can override. You want to override which element?
the third element, name of 2 equals to maybe
Yeah, so I just have to do names of 2. Whatever you give. Whatever. So that will replace your element with that. So next one is pop. If you have dealt with stacks, it is exactly the same as that. It will always return the last element in the list. So I have LST till 8, and if I do lst.pop, it will return the last element, which is 8. Now if I print lst, 8 would have vanished. Again I pop the last element. I have removed 2. That means it will actually remove from your data structure. So 2 has been removed, and if I print this, we see that 2 is gone. So if I do a pop again, I have removed 4, and if I print it, 4 is gone. So that is your pop function. That is one way to remove from the end. If I want to remove from a specific position, or if I want to remove a particular element, in that case I can actually use remove. So if I print LST, I see I have all these numbers. Suppose I want to remove the element 4. So I can say LST dot remove. I have passed 4, and if I print LST again, I see that 4 has been removed. That is the first occurrence of 4 has been removed. Right? Look at this again. Now I have this. If I want to remove the first occurrence of 1, then I have removed 1, and if I see this, I see that the first element has gone, and only the first is gone, not everything else. Suppose I want to remove the first occurrence of 2. In that case, I have to give 2 here. This is not indexing. This is actually I'm passing the element itself.
yeah, I wanted to give 4.
What 4? You want to remove this 4.
Yeah, the last.
There is a function for it. We'll see in the end. There is, to remove by index, there is a position. There is a function. Dot remove will basically remove based on the element itself. So if I want to remove the first occurrence of 2, then I have to say lst dot remove of 2, and if I print lst, I see that 2 is removed. So one more important question is the difference between pop and remove. We should be able to explain. So what pop does, it will remove the last element. It will pop out the last element, whereas remove will remove the element that you specify. Yeah, this is what you asked. Alternative to remove using index value is del function. Suppose I want to delete the last element. I have lst. Suppose I want to remove 5. In that case, I have to say del lst of -1. And if I print lst again, we see that the 5 is gone. So, we did pop. Yeah.
Basically, this works with the index.
Yes.
And remove works with the
Actual value. Pop will just remove irrespective of anything. It will just remove the last element. So we did remove, we did pop, and we did del. Remove will remove.
You think pop will work with both index and the value?
No, pop will remove the last element irrespective of anything.
If you give a particular value, will it pop out?
No, lst dot. You cannot pass anything here as far as I remember. Oh, you can actually pass an index. Remove and return.
Pop will work with the last value, right?
Should, but one second. Let's say I want to remove. What does this do? Yeah, it does remove by index. So if I give lst by default, if I don't specify anything, it will always remove the last element. But if I specify a particular index, like I want to remove the 5th element here, 0, 1, 2, 3, 4, 5. I want to remove this element, then I have to specify 5. So it should return 7. Right? 0, 1, 2, 3, 4, 5. Now we see that the element at the 5th position has been removed. So if I don't pass any argument to pop, it will always remove the last element. Any argument that you pass, it will remove the element at that index position. So pop, remove, and delete. We have 4 more functions: reverse, sort, and shallow copy and deep copy. These 3, I think we'll look at it on Monday. So I'll share this notebook as well.